Hello students, in this video we are going to discuss about arithmetic progression, geometric progression and harmonic progression. First of all, take a look at arithmetic progression. What is arithmetic progression? Suppose in a series the consecutive terms have common difference, then we say that that series is in a arithmetic progression. Okay, here I have provided one example 1, 5, 9, 13, 17 and so on up to 29. Okay, now what is the difference between 1 and 5? It is 4. What is the difference between 5 and 9? It is 4 again, and 9 and 13 also the difference is 4. So the consecutive terms between them, the difference is common, which is 4. Now this series is said to be in a arithmetic progression. Now how to deal with such series? Now if suppose a given series is in AP, then how to find sum of n numbers in that series? So for that the formula given is S is equal to n by 2 into A1 plus AN, where A1 is a first term in the series and AN is a last term in the series. In the above example, first term is 1, last term is 29. Then what about N? N is a number of terms in the given series. Okay, in the given series there are 4 terms, then N is 4. In the given series there are 100 terms, then N is 100. Okay, now how to find this nth term? We have one more formula to find nth term, which is nth term is equal to first term a1 plus n minus 1 into d, where d is the common difference. Okay, so if you substitute this value in this equation, we get the final equation. Sum of n numbers in series is equal to n by 2 into 2a1 plus n minus 1 into d. Okay, so where n is a number of terms in a given series, a1 is the first term and n is the nth term, number of terms in series, number of terms in series, and d is the common difference. Okay, now let us look at one example. Here we are asked to find the sum up to 1 or 2 terms. Okay, so let us solve this. We are given 11 plus 12 plus 1 plus 3 plus 5 plus 7 plus 9 plus so on. Okay, so the difference between 11 and 12 is 1. The difference between 1 and 3 is 2. The difference between 3 and 5 is 2. 5 and 7 is 2. 7 and 9 is 2. So in the rest of the series also the difference must be 2 only. So these two terms 11 and 12 have nothing to do with the rest of the series. So let us keep them aside. 11 plus 12, which is equal to 23. So keep it aside. Now let us look at the series which is in AP. Okay, so here 1 plus 3 plus 5 plus 7 plus 9 and rest of the terms are in arithmetic progression. Now what is the formula to find sum of terms in arithmetic progression? Now we are asked to find sum up to 1 or 2 terms. We have kept aside 2 terms already, so this will extend up to 100th term. Okay, the last one is not 100, it is the 100th term. Now how to find sum of 100 terms in AP? Okay, so we have the formula S equal to n by 2 into 2a1 plus n minus 1 into d. Now here what is n? N is 100 because there are 100 terms in the series upon 2 into 2 times of a1. What is a1 here? The first term is 1 plus n minus 1 into d. Again 100 minus 1 into d. What is d here? The common difference 2. Close the bracket. Now we get 50 times 2 plus 100 minus 1 99, 99 times of 2. Okay, so this is 50 times 2 plus 99 2s are 198. So we get 50 times 200. Okay, which is 10,000. 10,000. Okay, this is what sum of numbers from 1 to 100 term. But we left behind two terms which are 11 and 12. So the total sum is equal to 23 plus 10,000. So the answer is 10,023. This is the sum of one or two terms in the given series. Okay. So this is how we make use of these formulas for dealing with the series in AP. Okay. Now let us look at geometric progression. Series in geometric progression, if the terms increase or decrease by a constant factor. Okay, the series can be increasing or decreasing. If it is increasing or decreasing by a constant factor, we can say that that series is in a GP or geometric progression. Here I have given one example. Here take a look at the series 1, 2, 4, 8, 16 and then 32. Now let us perform 2 by 1. So if you perform 2 by 1, we get a value 2. Again perform 4 by 2. 4 by 2. So we get again 2. Again perform 8 by 4. We get again 2. So if you repeat this one, you are getting a common ratio 2. Okay. So these terms in series are increasing by a factor of 2. 2 times of 1 is 2, 2 times of 4 is, 2 times of 2 is 4, 2 times of 4 is 8, 2 times of 8 is 16. So here the common constant factor is what? 2. Okay. And we can say in the other way, the common ratio is also 2. So such series is said to be in a GP. Okay. Now how to deal with such series which is in a GP? First of all, we have to find common ratio in order to confirm that given series is in a GP. Okay. Once we confirm it is in GP, now how to find nth term in that series? This is the formula to find nth term in a given series, where R is common ratio, n is the number of terms in series, and a1 is the first term in the series. Okay. Now how to find sum of n numbers in the series? That is s is equal to a times, means the first number in the series, into 1 minus r power n whole divided by 1 minus r. So here again a is what? First term, r is common ratio, n is number of terms in the series upon 1 minus r. So here the condition is r should be less than 1. In order to apply this formula, the common ratio should be less than 1. Now what if the common ratio is greater than 1? Then we have to use this formula. S equal to a times r power n minus 1 upon r minus 1. Just the terms will reverse here. Now what if we are asked to find sum of infinite terms in GP? If the series contains infinite terms, how to calculate sum of those infinite terms in the GP? So here the first formula is sum of infinite numbers in GP is equal to a, means first term, by 1 minus r. How did we get this one? This one is derived from this formula. Okay, this formula is derived from this formula. Okay, the condition is r less than 1. Okay, now in this formula, if r is less than 1, that means the formula is s is equal to a times of 1 minus r less than 1. Let us take 0.5, suppose just one value 0.5 power, in place of n what we have to put? Infinity. Okay, by 1 minus 0.5. Now what it becomes? Now see, 0.5 is already a small number, and 0.5 power infinity, it becomes very negligible. It becomes negligible. So s is equal to a times of 1 by 1 minus 0.5. What is 0.5 here? R only, no? So the formula is 1 by 1 minus r. Okay. So this is what this first formula. A into 1 by 1 minus r. Now what about r greater than 1? What if r is greater than 1? Then sum of infinite terms in GP is equal to infinity. Okay. Now let us verify the second case here. If suppose r is greater than 1, this r is greater than 1, this r is greater than 1 and n is infinity. Something power infinity, the whole term becomes infinity. That is what written here. Okay. If r is greater than 1, the common ratio is greater than 1, then sum of infinite terms is also infinity. If r is less than 1, you make use of this formula. Okay. To understand this, we use one example. Take a look here. Now here we are given a series of infinite terms. Okay. Now the common ratio between first two terms is 4 upon 2, which is 2. Again 8 and 4. 8 upon 4, it is again 2. 16 and 8. 16 upon 8, which is 2. So what is r value here? R value is 2. Common ratio 2. And here r is greater than 1. What if r is greater than 1? If r is greater than 1, this is the formula we have to use. If r is greater than 1, sum of infinite terms is infinity. We can confirm that. Okay. Next, suppose the series goes like this. 4 by 8. How much is that? 1 by 2. Again 2 by 4. It is 1 by 2. Next, it is 1 by 2. 1 by 2 upon 1 is 1 by 2. So here common ratio is 1 by 2, which is less than 1. If the series is less than 1, if the common ratio is less than 1, then sum of infinite terms in series is a by 1 minus r. So substitute the values. A is what? First term, substitute 8 over here, and 1 minus r. Common ratio is 1 by 2, and you get 16. This is how you make use of sum of infinite terms in a GP. Now, harmonic progression. Simple one. It is just formed by taking the reciprocals of arithmetic progression. Suppose arithmetic progression is what? Between two consecutive terms, there is a common difference. A plus d minus a is a d. A plus 2d minus of a plus d is again d. A plus 3d minus of a plus 2d is again d. Okay. So this series is in a AP. Now just take the reciprocal of that series. It is what? Simply 1 by a and 1 by a plus d, 1 by a plus 2d, 1 by a plus 3d. So harmonic progression is just the reciprocal of arithmetic progression. Okay. Now let us look at this example. In this example, we are given some terms 1 by 2, 1 by 4, 1 by 6, 1 by 8, and this series extends up to 20 terms. Okay. And we are asked to find 16th term. What is the 16th term in this series? So to deal with this progression or this series, it is little complex. So what we will do now? We will convert this harmonic progression to arithmetic progression. Okay. Now if you look at the denominator terms, 2, 4, 6, 8, these are in a AP because there is a common difference 2. Okay. Now it is easy to find a 16th term in AP. What is the formula? Nth term is equal to a plus n minus 1 into d. So here 16th term is what? A. First term 2 plus 16 minus 1 into 2. So we get 32. So 32 is the 16th term in AP. Then what is the 16th term in HP? It is simply the reciprocal 1 by 32. Okay. I hope you understood minimum basics about AP, GP and HP. That's it for the day.